Previously, when we were asked to take the derivative of a function like this, the product of two functions, the only way we could take the derivative is we would have to multiply this out. So this is 4x squared plus 12x plus 9, and then your derivative, we can go from there, is 8x plus 12. So this one's not so bad, but I want to be able to actually take the derivative from here and go straight to here without necessarily multiplying out the function first. So this is where the product rule is going to help us. So in your notes, we're going to go through the product and quotient rule. So let's start with the product rule. The product rule says if you are taking the derivative of two functions, and let's call them f of x and g of x, then the derivative is going to be the derivative of the first function times the second plus the derivative of the second function times the first. So our first example has h of x is defined as this function times this. So think of this as your f of x, this is your g of x. So applying the rule, my derivative of h, so h prime of x, is going to be the derivative of the first function, which is 3 minus 4x, times the first, 5 plus 4x, plus the derivative of the second, which is just 4, times the first function, which is 3x minus 2x squared. Okay, so this is the derivative right here. Now we are going to practice the simplifying. So here, what you want to try to do is factor if you can. I don't see a common factor to pull out, so in that case, we're just going to multiply things out. So if I multiply things out, I'm going to end up with 15 plus 12x minus 20x minus 16x squared plus 12x minus 8x squared. Go ahead and combine your like terms. So my final answer here is negative 24x squared plus 4x plus 15. Let's try one with the trig function. So same idea. This is my first function, f of x. This is my second function. Think of that as your g of x. So g prime of x, the rule says we take the derivative of the first function, which is going to be 6x times the second, plus the derivative of the second function, which is cosine of x, times the first, which is 3x squared. And this one, there's nothing else you can do. This is your answer. You're done. Okay, now quotient rule. Okay, there's a rule for quotient of two separate functions. So the rule says when you take the derivative of quotient, you take the derivative of the top function times the bottom minus the derivative of the bottom function times the top all over the denominator squared. Now if you look at the quotient rule though, this looks exactly the same as the product rule, just the top piece, except the product rule has a plus sign, the quotient rule has a minus sign. Okay, so let's try this first example with the quotient rule. So f prime of x is going to be the derivative of the top is 3 times the bottom, 2x minus 1, minus the derivative of the bottom is 2 times the top, all over denominator squared. So that's my derivative. Now we always want to try to simplify, just so to practice the simplifying. I always look to try to see if I can factor something out. If you can't, then we're going to go ahead and multiply things out. So on the top, if I multiply things out, I have 6x minus 3 minus 6x over 2x minus 1 squared. So my final simplified answer is negative 3 over 2x minus 1 squared. Okay, one more with the quotient rule. Okay, so y prime is going to be the derivative of the top, which is 5, times the bottom, minus the derivative of the bottom is 2x, times the top, all over denominator squared. Okay, again, let's try to simplify this. I don't see something I can factor out on the top, so I'm going to go ahead and just multiply it out. 5x squared plus 5 minus 10x squared plus 4x. Combine like terms on the top. So my final answer is negative 5x squared plus 4x plus 5, all over x squared plus 1 quantity squared. Okay, let's try the last two, one product, one quotient. Okay, product rule here, f prime of x, derivative of the top, derivative of the first function is 2x minus 2 times the second plus the derivative of the second function is 3x squared times the first. Now this one we are going to simplify by factoring first. We always try to factor if we can before we start multiplying things out. If you multiply it out, it's going to be difficult to try to factor it after the fact. I notice here there's a 2 I can pull out. That leaves me with x minus 1. This is your difference of cubes. This is going to factor to x minus 1, x squared plus x plus 1, plus 3x squared. This also factors to x minus 1, x minus 1, or x minus 1 squared. So I'm going to factor it, and now I can go ahead and pull out a greatest common factor. So this is all one term, this is all one term, and what you'll notice is both of them have an x minus 1 squared that I can factor out. So I'm going to pull out the x minus 1 squared from both terms, and that's going to leave me with 2 x squared plus x plus 1 plus the 3x squared. After you have factored, then whatever's left over, that's what you're going to multiply out, because you always want your answer to be in factored form. And if I multiply all this out, I'm going to get to here. So you always try to factor first, and if you can't factor, then you multiply out. Okay, last problem with the quotient rule. Okay, so f prime of x is going to be derivative of the top, which is 2x plus 2, times the bottom, minus derivative of the bottom, 2x, times the top, x squared plus 2x, all over denominator squared is going to give me x to the 4th. Okay. Now, when I try to factor, I'm trying to see if there's anything I can take out that's common to both. Here you can pull out the 2, but that's about it. So if you want to just multiply this out first and pull out the 2, that is not going to be a problem as well. I'm going to multiply it out, 2x cubed plus 2x squared minus 2x cubed minus 4x all over x to the 4th, and this will leave you with this. Now you can factor out a 2 here, so you can write your answer like this, but the reason why I want to factor is I want to see if there are things that I can cancel, and there isn't, so either one of these would be fine for your simplified form.